All right, welcome back. So this time we're going to talk about AWS Step Functions. But before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. So Step Functions are a serverless orchestration service coordinating multiple AWS services into automated workflows through visual state machines. It functions as a workflow engine connecting AWS services with support for branching, retries, parallel execution, error handling, logging, and long-lived jobs. Step Function suits machine learning pipelines, orchestrating SageMaker jobs, data processing workflows, covering ingestion through transformation to storage, ETL operations, microservice orchestration, and job monitoring and control. So, how does this work with the machine learning pipeline automation? AWS-based machine learning or AI systems require sequential steps: data preprocessing, model training or tuning, model deployment, and post-processing for scoring and evaluation. Step Functions automates these steps without complex glue code, provides retry logic with parallel processing and branching, integrates directly with SageMaker, Lambda, Batch, Glue, SQS, and SNS, and enables batch transformations and automated hyperparameter tuning. And it offers auditing with replay capabilities for traceable machine learning workflows. Right? So real-world applications automate SageMaker XGBoost training, followed by batch inference and result storage through single-state machine definitions. So what's the pricing look like for Step Functions? So Step Functions offers two workflow types: a standard workflow that costs about 2.5 cents um, per thousand state transitions, and it suits long-running auditable workflows up to 1 year. Express workflows cost about $1 per million invocations, plus I want to say about 4 millionths per gigabyte second of compute, plus IO costs. So this is designed for high volume, short duration workflows up to 5 minutes. So what's the state machine architecture? All right. So state machines define overall workflow structures as series of states and transitions. States represent individual workflow steps like Lambda invocations, wait periods, or choice logic. Amazon State Language, ASL, uses JSON-based specifications for state definitions. You don't need ASL syntax knowledge for the exam, but you should understand the state type purposes. So let's talk about state types. All right. Is this the state types? That might not be it. Is that it? I think that is. Amazon States Language. Um, let's see. Let's see if we can get the right one. All right, let's state types. So task states run on Lambda, right? So they run on Lambda functions. They run on ECS tasks, SageMaker jobs, or API integrations. Choice states implement branching logic through if-else style comparisons. Wait states introduce delays using seconds or timestamps before the next steps. Parallel states run multiple branches simultaneously for operations like transform and log. Map states iterate over dataset items, running steps in parallel on each. Pass states transfer input to next states unchanged for debugging or structure. Succeed states mark successful workflow ends. Fail states terminate workflows with failure status. Map runs in parallel per list items, while parallel launches separate branches regardless of the input size. It's a lot, right? Okay, so let's go in the console and see if we can do this a little quickly. Okay, so let's see, state. Let's see, state machines. All right, so we'll clear some step functions. All right, so create from blank, standard. Oh, step test. All right, and then you can author the workflow here. So the default is the Visual Studio, right? Or you can drag and drop states, or you can do the Amazon States Language editor with the JSON, right? Right here. Okay, and then you can click start with a template, choose the training machine learning model, and load pre-configured SageMaker tasks. So you could have a template that we saw when we were going back. It would have actually been right before we did everything up front. All right, but the template would include Lambda functions, training data, SageMaker training jobs for XGBoost or similar algorithms, right? It could have SageMaker model creation, SageMaker batch transform. There's a bunch of different things. And so within this, you can configure task states. So you can have each task point to a service like Lambda for pre-processing, SageMaker for training jobs, tuning jobs, or Glue, Batch, API Gateway, et cetera, for other operations, right? And you can pass parameters between steps and define retries, timeouts, and error handling, right? So you can say, S3? I don't know. Look, I don't know. All right. So from here, you can add branching logic. JSON data, JSON. So, all right. And then you start adding and adding and adding, right? So you can have a branching logic. You can configure timing. Okay. Multi-part upload. Lambda invoke, right? And you can see all these options, right? Next state, Lambda invoke, next state, and then you can start building in certain things here, right? So this takes a while to set up, but you need to really learn the logic and get some practice in it. Okay. Okay. So how would you do this in production? All right. So SageMaker training with a batch inference would have a different flow. All right. Let's see if we can see. Oh no, let's go back. Let's replace that. All right. So you could have a generate data set. All right. And then train. Let's train models, create train models. And then maybe like a create train model. And then batch. Let's see, where is it? And then let's say create job queue, right? So you could have this set for like a very simple SageMaker with a batch inference. All right, this is not going to work. So if you try this, believing that I know the way, yeah. But think about all the different types you could do with, let's say, tuning a model, right? Oh, okay, so all these models under SageMaker, right? You have the create model, invoke model, customize model, right? You could have it set to generate the data, tune the model, get the best model, deploy, and score, right? You could have an ETL job where you have the S3 bucket, right? It has the S3 here to get this, map it, right? For something like EMR, that would be an example, right? And then have it stored to an S3, right? So you can have it run a whole jobs through this automated workflow, or you could do it through JSON, right? I'm just giving you a decent quick pass through. Okay. So how does this work with other services? So Step Functions integrates with over 200 AWS services through SDK integrations. Lambda provides custom compute steps. SageMaker can handle training, tuning, deployment, and transformation. Glue can manage data cataloging from ETL. DynamoDB can persist setup steps and then results. SNS and SQS can provide notifications and queuing, and then Batch can run long-running compute tasks. And Athena can query S3 datasets. So think of all the things you could do with that. So for the exam, remember a couple of essentials. When questions ask about orchestrating ML workflows, coordinating multiple AWS services, or managing sequential and parallel machine learning pipeline stages with error handling, Step Functions provides the serverless orchestration layer, automating complex AI machine learning workflows from data preparation through model deployment. So I hope you enjoyed that. Before we get going, hit the like button, subscribe, share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.